This video is to help you with the concepts of independent and dependent events from sections 5.2.3 and then to talk about the homework. So first of all, we have a definition of dependent and independent events. Two events are considered dependent if the outcome of one event affects the probability of the other event. So one depends on the other, so it's called dependent. For example, if one card is drawn out of a deck of cards, then the probability the first card is red, 50 or 26 out of 52, or half, because 26 of the 52 cards are red, half the cards are red. But if you don't replace that card, the probability of the second card now depends on the result of the first selection. So if the first card was red, now there's only 25 red cards remaining, and the deck only has 51 cards in it. So the probability of a second card being red is 25 over 51. The second event, selecting the second card, depends on the first. So the reason we care about whether something is dependent or independent is because if it's dependent, then the second scenario depends on the first, so the probability will change. If the outcome of a probabilistic event does not affect the outcome or probability of another, then we say that the events are independent. So for example, assume that a normal six-sided die is being rolled twice to determine the probability of rolling a 1 twice. The result of the first roll does not affect the probability of rolling a second one. The probability of rolling a 1 on the first roll is 1/6, and then the probability of rolling a 1 on the second roll is also 1/6. So the probability of rolling 2 ones in a row is just 1/6 times 1/6 equaling 1/36. So when you have independent events, you can multiply to have the probability of both occurring. With dependent events, the second probability depends on the first, so it becomes a little more complex to calculate and figure out that probability. With independent events, you just have to multiply the probability of one thing occurring times the probability of the other thing occurring, and that's the probability of both of them occurring. So one of the things they have you do in the classwork problems is to just identify these as to whether they're dependent or independent events. So flipping heads on a quarter and then flipping another heads is independent because flipping a coin and then flipping it again, the second flip does not depend on the first. Choosing a jack from a standard deck of cards, not putting it back in the deck, and then choosing a king. That is dependent because there's now one less card in the deck, which changes the probability of picking a king. Again, the key wording here is you didn't put that first card back in the deck. So now you've altered the deck. There's 51 cards in it, and you've altered the deck that there's one less jack. So it affects the probability of choosing a king because you did not return that first card. C, picking a blue marble from a bag of marbles, putting it back, and then picking a blue marble again. That is independent because when you replace the marble, the probability went back to being the same. So the key again here is you put the marble back, so therefore you've not affected the original sample space, you've not affected the probability of the second event. And then rolling a 6 on a number cube 3 times in a row. Again, that is independent. Each time you roll a number cube, it's like a fresh start. It hasn't changed. The number cube itself hasn't been changed. The probability has not been changed. For your homework, you're doing 549 through 553. So for 549, they want you to decide if it's dependent or independent. And then again, we're looking at the same concept. Dependent if the outcome of the second event depends on the outcome of the first, and independent if it does not. So what's the probability of spinning a 3 on a spinner after having just spun a 2? So what you want to think about is, has the spinner changed? If the spinner has not changed, the probability of spinning is a fresh start every time you do it. So we'd consider that independent event. For B, probability of drawing a red 6 from a deck of cards after the 3 of spades was just drawn and not returned to the deck. So again, the card has not been returned to the deck, so you have to think about, is your probability of the second event affected by that? You've taken out a card, you didn't put it back in. Have you changed that original sample space? Have you changed that deck of cards? If so, then it's dependent. Probability for C of drawing a face card from a deck of cards after a jack was drawn and replaced and the deck was shuffled again. So if you replace the jack and then shuffle it again, have you changed the deck of cards? If not, then it's independent. And the probability of selecting a lemon lime soda if the person before you reaches into a cooler full of lemon lime sodas, removes it, and drinks it. So have they changed what was in the cooler? Have they changed the sample space? If so, dependent. For 550, Sky's ice cream shop is Mario's favorite place to get ice cream. Unfortunately, because he was late arriving there, his friends have already ordered. He didn't know what they ordered for them. They told him it was either a waffle cone or a sundae, and the ice cream flavor was apricot, chocolate, or blackberry. So first they want a list of all the possible ice cream orders. So he could have the waffle cone with the apricot, the waffle cone with the chocolate, the waffle cone with the blackberry, sundae with the apricot, sundae with the chocolate, sundae with the blackberry. And then what's the probability that he will get something with apricot ice cream? So looking at your list of possibilities, how many of them include apricot ice cream? Write that as a probability out of the total number of possibilities. And then what's the probability that he'd get a sundae? Again, count up the number of sundaes out of the total possible, and so on. All right. 551, they want you to sketch this algebra tile shape, write expressions for the area and perimeter, and then calculate the area and perimeter for the x values. So the x values are given to you. So you're going to have a couple of different answers here. You're going to have an expression for the area, an expression for the perimeter, and then they're going to give you x values, and you're going to find the area and perimeter with each of those x values as well. 552, Elin has made 29 note cards for her friends. She plans to send out a total of 40 cards. What percentage of cards has she finished? So basically, what is 29 out of 40 as a percent? 553, simplify these expressions by combining like terms. Remember, we typically will put the x to the second power term first, if there is one, and then the x term, and then the constant term, the number term, when we put them in order after we've combined our like terms. So that's your homework. Please let me know if you have any questions. Thank you.